Hey guys, so welcome back. This video is going to be dedicated to really everything about lines. These are the practices that really I came into contact with when I took the SAT and ACT. And I think they're really important to know for any questions that are dedicated to lines, slope, anything about that. Alright, so let's get started with slope-intercept form. On the SAT and ACT, I came in contact with slope-intercept form the most out of any line problem. And this is the equation that any line is in, that it can be forced into, basically. And it's extremely important to know this. So, this is the basic equation for a line. So it's y equals mx plus b. And in this case, m equals the slope, and b equals the y-intercept. B equals the y-intercept, so the y-intercept is pretty self-explanatory in that on a coordinate plane, it's where the line hits the y-axis. The y-axis being this one. That is the y-axis for you. Alright, so that's the place where that line hits it, wherever on the y-axis. But this m equals the slope. So the slope is how much the line moves up and out, basically. So the way to calculate the slope, or the way to think about the slope, is really rise over run. So it's basically with every step, I rise a certain amount of points, and then I run a certain amount of points horizontally. So first it's vertical, then it's horizontal on that one. And not every slope is unique to the line, but any lines that are not parallel have different slopes. If they are parallel, which the SAT and ACT, this is a trick that you need to use, if they say the lines are parallel, that means that they have the same exact slope. Remember that because that comes up on a lot of problems. Alright, so right now I want to take you through a lot of the common types of problems that you'll see with lines. These are the three that I think are most important, that you see the most, whether they be the actual question or just embedded in the question they ask you. Alright, so let's start off with the first one. So this is when they ask you to find the slope of a line. And usually in order to do this, they give you 2 points. And here in this example, the question I have is find the slope of a line with the points 0, 3 and 2, 6. And just if you didn't know, these are ordered pairs. So on a coordinate plane, if it was 0, 3, it's y. This is the x value, and that's the y value. So if you have x, you go across 2, and it's the y, you go up 6. Just like that. Alright? So it's saying find the slope of a line with the points 0, 3 and 2, 6. So there's a very unique formula that you need to use to find the slope, and what it looks like is y2 minus y1 over x2 minus x1. And you may be confused by the numbers that they use beside them, but don't worry. It's literally to say the second ordered pair is y minus the first ordered pair is y, or the second ordered pair is x minus the first ordered pair is x. Alright, so in this problem, this would correlate to, so the y of the second one, and I'm making this the second one, that would be 6, right? Because that would be the y value of the ordered pair in the second equation. And then you subtract the y of the first term, of the first ordered pair, which would be 3 in this case, since it's the y of the first ordered pair. So it's 3, then you have it over. And then we're going to look for the second x. Alright, so you go to the second ordered pair, it's the x value of that second ordered pair, which in this case is 2. Right, and then you subtract, and then you go to the x value of 1 with the first term. So you go to this ordered pair and you find the x value, and it's 0. Right? And then we're going to just simplify this, and it'll help you find your slope. So first we're going to have 6 minus 3, which is equal to 3. And then 2 minus 0 is equal to 2. So it's just 2. Right? And that is equal to your slope. So if you go through it one more time, these are your ordered pairs. You're going to take the y value of the second ordered pair first, plug that in, minus the first ordered pair's y, which in this case would be 3, so 6 minus 3 on the top, and then on the bottom in the denominator, it's the second order pair's x value, which in this case is 2, and then you have the first order pair's x value, which in this case is 0, so it's 2 minus 0, then you simplify all that out, so 6 minus 3 equals 3, and then 2 minus 0 equals 2, and that would equal your slope for this problem. And if they ask you to go a bit further, remember, in slope-intercept form, the m in this problem equals the slope. So if you were to write the equation, it would look a bit like this, equals, and you would have your slope as 3 over 2x, and then it doesn't matter what your y-intercept is in this case, so I'm just going to leave it as b, but that's where the slope would go in your slope-intercept form if they made you do that. So let's move on to the second one of finding the intersection. So in these types of problems, it's finding the intersection between two lines. So when they're going to ask you this, they'll either phrase it as find where these two lines meet, find where they hit, find where they merge, things like that. But you just always need to go back to the find that you're trying to find out where they intersect. So in this case, the example is find where y equals x plus 7 hits y equals x or 3x minus 2. Alright, so these types of problems may look a little difficult, but they're actually very easy because all you need to do is set, since x plus 7 equals y and 3x minus 2 equals y, you can just set them equal because they're both equal to the same thing. So in order to start solving this, your first step is to write this out as x plus 7 equals 3x minus 2. Because remember, you can set them equal to each other, and that's your starting point. Okay? So first, you're going to try to solve this and solve for x, basically. So in order to solve for x, I like to focus on the x's first. So I'm going to subtract x on both sides, right here, subtract it on both sides, and make this 2x times 2 equals 7. But then, if we're going to keep solving for x, then we're going to add sides, and that's going to get you 2x equals 9. And then in order to get that x alone, you're just going to divide by 2 on both sides, and that's when you get 9 over 2 equals x. So that's the x value. That represents the x value of the point where these two lines hit each other. So I'm going to write that off to the side here of 9 over 2. All right. So then all you need to do is plug this x value in to either of these two equations. You can pick which one, it does not really matter, because you know that x value, or this point, since it's where these two lines meet, you know that point is on both of these lines. That's why it does not matter which line you decide to plug in your x value to. Right? So let's keep solving. So I'm going to plug it into this one since it looks pretty easy, since there's no number to multiply that x by. So let's do y is equal to 9 over 2 plus 7, right? And in this case, it helps my brain a little bit to make 9 over 2, which is equal to 4.5 actually. So you can make that 4.5 plus 7 equals 5. And then if you just keep simplifying this of 4.5 plus 7, it's y equals 11.5. So let me change this, make it all decimals just so it's a little easier. 4.5, and then your y value, parentheses, go. So that is how you solve for the ordered pair of where these lines hit each other. And that's how you do it. Alright, so now we're going to go to that third problem that you'll see on the SAT and ACT, and that's whether you can distinguish, is this point on the line? If they give you a random point, they'll also give you a line, and you can say, oh, this point actually lies on this line. So in this problem, that's what we're going to do. And these problems are actually pretty simple. So what you're going to do is, in this problem, is 1, 3 on the line y equals negative 2x plus 4. Alright, so in this one, all you're going to do is plug in both of these numbers. So remember how I was saying that this is the x value and this is the y value? You're just going to plug that in, alright? So your y value is 3 equals negative 2, and then you can make that a 1. Alright? So in these types of problems, then you just solve and you see if it actually matches up. So what we're going to have is 3 is equal to, and then we're going to multiply negative 2 times that 1, because if you were to plug in the 1, it would just be negative 2 times 1. And that'll give you negative 2, and then you have the plus 4. But now that you see, if you simplify this by making it negative 2 plus 4, which is equivalent to 2, you can see that 3 equals 2. 3 doesn't equal 2, and it can't, which is why it does not equal that, and it shows that 1, 3 is not on this line. It has to equal the same number for it to be on the line, and this is a very easy way to tell if that ordered pair is on the line that you see. Alright, so just a quick rundown of what we did in this video. So we talked about slope-intercept form of this y equals mx plus b. Remember, m is always the slope, and b is always that y-intercept of where that ends. Let me just make sure that you understand that. So let's say that that was your line. This would be your y-intercept because it's where it hits that y-axis, just so you know. Right? And the 3 types of problems that you'll see: finding the slope given 2 points, finding the intersection given 2 lines, and distinguishing whether that point is actually on the line. If they were to give you the point and the line, seeing if that point would be on the line that they give you. Alright, so yeah, just tell me if you have any questions about this video, and I hope you liked it.